everyone, myself Sai Prasad, a lecturer in Ahmedabad High School and the Junior College. Welcome to a series of the lectures of 9th class maths. We have learned different chapters in this 9th class. We learned what is polynomials and all other different basic chapters, right? Today we are going to start the basic chapter of geometry, that is the elements of geometry. What do we learn? What we'll learn in this chapter? That is, we'll learn the basic theory behind the geometry. Okay, there's a very simple chapter with only a theoretical background of what is geometrical shape and what is geometry and everything. How do we equate it? How do we realize them? Okay, and what is the kind of relation we can develop between them? Is it clear? Basically, we are going to learn two things in this chapter. That is, one is the axioms. Axiom is simply, we can tell it as a simple notation or a minimum basic condition. Is it clear? The minimum condition to understand a particular statement, that is nothing but axiom. And the second thing is postulate. Postulate is a kind of formula, right? Or else something which gives a basic rule for a example. Is it clear? Shall we start? See here. These are all the different axioms given by Euclid. Euclid is the main person who designed the whole geometrical part, that is the basic division rules and everything. Clear? See here. The first axiom, see here. Things which are equal to the same things are equal to each other. What do that mean? For example, I have two things A, B, C. Right? I tell there are two things A and B. These are equal to the same thing. Okay? I tell that A is equal to C and B is also equal to C. Then obviously A is equal to B. Yes or no? Once again, see here. The things which are equal to the same thing are equal to each other. Right? Did you understand? Fine. See this next question. If equals are added to equals, then the wholes are also equal. Let us take three different variables. Let us take A equal to B, C equal to D. Okay. If I tell A plus C, or else let me tell, if I tell A plus C is equal to some kind of X, then obviously if I tell B plus D something kind of Y, then I can directly tell that X is always equal to Y. Why? See here, the equals are added to equals. These equals are added to these equals, then the whole or else the addition is also an equal. Clear? Fine. See this next. If equals are subtracted from equals, if I say A minus C is something X or B minus C is something Y, obviously those both remainders are also equal. Is it clear? Or you can say remainder or difference or whatever. Clear? Fine. Things which coincide with each other are equal to one another. Coincident in the sense, for example, these both meet at this particular point. What do this mean? This line also passes through this point, this line also passes through this point. Coincident in the sense, exactly, we can tell it as like this. If one line passes onto the another, obviously both the lines are equal. Okay? And the next, the whole is always greater than a part. Okay? If I tell this is a whole numbers ka set, if I tell there is one number 5, okay, 5 is a part of number set, yes or no, which means this whole is always greater than this single part. Clear? Next, the things which are double of the same things are always equal to one another. For example, A is equal to B. Okay, if I tell double of 2A is some C, double of 2B is some D, obviously C will be equal to D. Yes or no? If I take 5 and 5, double of 5 is 10, double of, again that is a simple example. Clear? The things which are double of the same things are always equal. Clear? Next, the things which are halves of the same thing are also equal. If I say A by 2 is C, B by 2 is D, obviously C is equal to D since A is equal to B. Clear? Did you understand? This is a broad view and the theoretical approach of defining any two equal numbers or those kind of numbers. Is it clear? Shall we move on to what are the postulates and everything? Let's do. See here, the next these are Euclids postulates. These are also almost the same, but mostly these are based on the geometrical identification. See here, he is telling there is only a unique line, unique means only one, that passes through given two distinct points. If I say there are 2 points A, B, how many lines can I draw from those 2 points? Maximum I can draw only one line that can be passed through given 2 points. Yes or no? Is it right? What's the first statement? There is a only unique line that can pass through two distinct points. Is it clear? Fine. A line segment can be extended on the two sides to form a line. For example, A, B is a line segment. We can extend this side or we can extend this side in order to form a straight line. Is it clear? Yes or no? That is a simple statement, but those are the prerequisites and the basic theory. Clear? See here. We can describe a circle with any center and any radius. For example, if this is the center, we can draw a circle with some radius. Let us say some 1 centimeter. I can draw with the another center, I can draw one more circle with some radius 3. Yes or no? I can draw any circle with any radius and from any center. Clear? Fine. All right angles are equal to one another. What do you mean by right angles? Right angle is the angle 90 degrees. Wherever you draw, whether you draw like this or you draw like this. However, the 90 degrees will be same. Clear? Fine. And the next, see here. If a straight line falling on two straight lines, let us assume these are two straight lines. Okay. Let us say it as LM. He is telling a straight line, one more straight line N. Okay. Is falling on this straight line, making an interior angles which is same side are less than two right angles. See here, this interior angles, let us say these both, right? If the sum of these two lines are always, if it is less than two right angles, then L and M are not parallel at all. Is it clear? Yes or no? If it is less than 180 or else two right angles means if it is less than 180, or else we can directly tell if these both are not parallel, obviously the internal sum either this side or that side should be less than 180. There is an extra statement, don't think of that, just to make you understand I have written that. Clear? Yes or no? If both are parallel, what happens? If both are parallel, if I add those both angles, I will definitely get it as 180. Yes or no? Because those both angles will be same. Clear? You do understand? Fine. Yes or no? These are all the basic postulates of Euclid. What are those postulates? The first postulate is there is a unique line that passes through a given two distinct points. Okay? And a line segment can be extended on the both sides in order to get a line. Next, we can describe a circle. We can describe any circle with any radius with any center. Clear? And the next, all the right angles are always equal to each other. Okay? Next, if a straight line is falling on the two straight lines, then the sum of interior angles is always less than two right angles. That is 2 into 90 is 180. Is it clear? Shall we do few problems of the exercise of this chapter? Let's do. See here the question, that is he is telling if a point Q lies between P and R. What does that mean? That is there is some points P and R, so that he is telling Q is a point in between. Okay, Q is a point lying between P and R. Okay, then he is telling such that PQ is equal to QR. Okay, let us say PQ has some distance A, QR has some distance A. Okay, let PQ is equal to A, QR is equal to A. Is it fine? Now he is telling PQ is equal to half of PR. How do we write? Right, first find PR. PR is PQ plus QR. What is PQ? A. Here also QR is A. This is PR. Okay, therefore PR is 2A. Is it fine? Now, what is PQ? PQ is nothing but half. He is telling half of PR. Just check or else find half of PR. Half of PR is equal to half of 2 into A. 2 to cancel A. Half of PR. What is A? Can I write A as PQ or QR? Yes, right. Therefore, half of PR is nothing but PQ. Is it clear? That is what he asked us to prove. Once again, he is telling PR are 2 points in between. Q is a point such that this is equal to this side. Fine. Then PR is equal to double of this PQ. Or else PQ is simply a half of PR. Clear? Did you understand? See here, next question. Draw an equilateral triangle of 5.2 cm each, it seems. Okay. How do we draw? Just draw a line segment AB of side 5.2 centimeter. Okay. And the next, with A as center and radius as 5.2, draw an arc. Okay. Similarly, with B as center, 5.2 as radius, draw one more arc. Just join these 2 points. This is also 5.2, this is also 5.2 centimeter. Clear? Don't forget to write the steps for this. What's the first step? Draw a line segment AB with a length of 5.2 centimeter. Then with A as center and 5.2 centimeter as radius, draw an arc. And the next again B as center, 5.2 centimeter as radius, draw one more arc cutting the previous arc. This point is C, then join AC and BC. Clear? Therefore, ABC is a triangle required. Is it clear? Fine. And one more definition. What is conjecture? Conjecture is simply a statement which is actually true. We can directly see it, but we can't theoretically prove it. Yes or no? Just now we have seen the different axioms and postulates, right? Is there any proof for them? Tell me, the half of this equal to half of this. Just we can see it. Yes or no? For example, there was one postulate that any circle, we can draw a circle with any radius and any center. Yes or no? Is there any proof for that? No, right? That is one of the statement which is simply called as a conjecture. Okay, see the definition. A statement likely to be true based on the available evidence. Yes, we know we can draw any circle with any center from any center. Any radius at any center. Clear? Yes, we know that. Can we prove it? Yes, if you want me to prove, I can prove by drawing it. We don't have any formal proof as we used to prove in all other sums of maths. Yes or no? That's it. That is the statement. If you want me to give an example, you can write this example. A circle can be drawn from any center with any radius. Clear? Is it fine? These are all different basic theoretical approaches of what is geometry. Clear? Did you understand? What did we learn in this lesson? We started with the basic axioms, right? Then we learned different postulates. Then we did few problems which are resembling the postulates and axioms. Is it clear? Did you understand? Fine. This is for today. Let us meet in the next session with a new chapter of 9th class. Thank you.